Hello everyone, my name is Kishan Agarwal. I'm today going to present my concept video of discrete mathematics and structures, and my topic is Kruskal's algorithm. So before going to Kruskal's algorithm, let us see what is a tree. Tree is a data structure that is non-linear data structure and a hierarchy consisting of a collection of nodes such that each node of the tree stores a value and a list of reference to other nodes. So this data structure is specialized method to organize and store data in computer to be used more efficiently. It consists of central node, structural node and subnodes which are connected via wedges. We can also say that tree data structures has roots, branches and leaves connected with one another. So what is a spanning tree? A spanning tree is a subset to a connected graph G where all edges are connected. So what is a connected graph? Connected graph is a graph if all the edges are reachable within a graph, so we can call it as a connected graph. So spanning tree is a subset to a connected graph G where all the edges are connected, that is one can traverse to any edge from a particular edge with or without having intermediates. Also a spanning tree must not have any cycles in it. Thus we can say that if a tree have n vertices in a connected graph, then the number of edges that a spanning tree must have is n minus 1. So given a connected graph and undirected graph, a spanning tree of that graph is a subgraph that is a tree and connects all the vertices together. That is, a single graph can have many different spanning trees. A minimum spanning tree or minimum weight spanning tree for a weighted connected undirected graph is a spanning tree with a weight less than or equals to the weight of every other spanning tree. The weight of a spanning tree is the sum of weights given to each edge of the spanning tree. So how many edges does a minimum spanning tree has? So we can say that every tree is a graph, but it need not to be vice versa. That is, every graph is a tree. So here we are discussing about spanning tree, which is, we have discussed that it should not have any loops that are or cycles. So how does a spanning tree forms? We have discussed that it is formed using n minus 1 vertices edges, there where n is a vertices. So how many edges does a minimum spanning tree has? A minimum spanning tree has v minus 1 edges, where v is the number of vertices in the given graph. So what are the applications of minimum spanning tree? Why do we use minimum spanning tree? We use minimum spanning tree for network designs, learning silent features for real-time face verification, cluster analysis. Even spanning tree is used to calculate the shortest distance between two destinations, and many other applications we have for minimum spanning tree. And there are many methods to calculate minimum spanning tree. In this, Kruskal's method or Kruskal's algorithm is one of the method. So how to find MST, that is minimum spanning tree, using Kruskal's algorithm? So what are the steps? Mainly there are 3 steps to be followed to find minimum spanning tree using Kruskal's algorithm. First step is to sort all the edges in a non-descending order, that is in ascending order of their weights. Next step is to pick the smallest edge, check if it forms a cycle with the spanning tree formed so far or not. If the cycle is formed, include the edge, else discard it. That means if any cycle is not forming, if we are adding that edge, you have to include it. Otherwise we have to exclude that edge, particular edge, if it is forming a cycle. Next, third step is we have to repeat the second step until we reach v minus 1 edges in the spanning tree, or we can say that every vertices have been included in the spanning tree. So kruskal's algorithm to find minimum cost spanning tree or minimum spanning tree uses the greedy approach. That is, the greedy choice is to pick the smallest weight edge that does not cause a cycle in the MST constructed so far. So let us see an example to form with a given graph and how to approach or to how to find the minimum spanning tree. So let us consider a graph with 9 edges and 9 vertices and 14 edges. So that minimum spanning tree formed will have 8 edges, that is 9 minus 1, 9 is your vertices, and if we want to find the number of edges in the minimum spanning tree, so we'll get 9 minus 1, that is 8 edges. So we'll start by the step 1. What was the step 1? Step 1 was to sort all the edges in non-descending order, that is ascending order of their weights. So first of all, here I have arranged all the edges in their ascending order of their weights. Next step is to start forming the tree, and we have to check whether the particular edge should not form a cycle with the given or with the tree which we are constructing. So first we will select the first edge, which is between 7 and 6 with minimum or least weight. So 7 and 6. After picking 7 and 6, we can see that no cycle is formed, so we are including this 7 to 6 edge. Next, the minimum or with the least number the edge is 8 to 2, which has the weight 2, so we are including that. Here there is no connection between these two edges, so we are drawing it separately, and here no cycle is formed, so we are including this edge. Next we have the third edge, that is 6 and 5 with weight 2. Here also, if we are including this edge, no cycle is formed, thus we include this edge. Our next edge is 0 to 1, which has a weight of 4, and we see that after adding this edge also we are not able to find any cycle, so we are including this edge even. After this, we have a edge between 2 to 5 with the weight of 4, and thus adding that edge to the tree we are not able to find any cycle, so we are including that edge even. Our next edge is 8 to 6, but if we draw a edge between 8 to C, we can see that it is resulting in a cycle, so we are discarding it, we are not including that 8 to 6. So our next edge is 2 to 3 with a weight of 7, and it is not forming any cycle, so we are including it. Let us count the number of edges: 1 2 3 4 5 6. There are only 6 edges till now, so we want 8 edges, so we'll add we are going to add the more edges. The next edge is 7 to 8, but if we add a edge between 7 to 8, this edge results in a cycle, so that's why we are discarding it. Next we have to pick the another edge which is between 0 and 7. So 0 and 7, this doesn't form any cycle, so we are including that edge with a weight of 8. Next we have to pick an edge. Next edge is 1 to 2. If we add a edge between 1 to 2, you'll get a cycle, complete cycle, so we are discarding it. Next is 3 to 4, so with weight 9. and it is not forming any cycle, so I am including that edge into our minimum spanning tree. So since the number of edges included in the minimum spanning tree is equals to v minus 1, that is 8, so we got our minimum spanning tree. This was a very basic example to implement Kruskal's law to find minimum spanning tree for a given graph. So if we look at the time complexity to find the minimum spanning tree using this algorithm, which is big O of n log n, or we can say that sorting of edges takes place in the time of big O of n log n. After sorting, we iterate through all the edges and apply the find union algorithm. To find and union operation can take at most big O of log n time. So overall complexity is big O of n log n plus big O of n log v time. So the value of E must be big O of v square. So big O of log v is big O of log E, the same. Therefore overall the time complexity is big O of E log E or big O of E log v. The space complexity. Space complexity is big O of v plus E, where v is the number of vertices and E is the number of edges. So this was about using the Kruskal's algorithm to find the minimum spanning tree, and we have discussed even the time complexity of minimum spanning tree using Kruskal's algorithm. Thank you.